And we're live. Okay, I see some people joining in already. Joshua says he was here first. That is correct. Hey, Kalash. Nice to see you here virtually. And okay, folks. So I'm basically tuning in from New Delhi, India. Tony, where are you based out of?
Hey Arshit, I am from Pune, Maharashtra.
All right. So,
So
folks, by
yeah,
all means, let us know where you are all tuning in from. Jillian says she's here fifth. That is correct as well. All right. I see Sachin tuning in from Bangalore. We have Petra from Prague, Priya from Munich, Mohammed from Dubai, Ines, Sai Krishna. Hello. We have people from New Jersey, pretty much all around the world. People are tuning in. And yeah, I guess we are a minute up, and it's about time we get this session started. So, hello everyone, and welcome to another exciting session of TestMu 2024. And I'm Harshit Paul, Director of Product Marketing here at Lambda Test, and I'll be your host for this session. A very warm welcome to all the attendees who are joining us from all around the globe. It's fantastic to see such a diverse and engaged audience here with us. Today, we will be talking about automated testing of AI and ML models. But before we get started, a few housekeeping items. This webinar is recorded, so in case you need to drop off midway, don't worry. You'll get the full recording of this webinar over your registered email address. You can also find the full recording of this session over the TestMu AI Meet platform from where you're tuning in right now. And we will also be uploading all of these videos to Lambda Test YouTube channel. So in case you're not already subscribed to Lambda Test YouTube, do that so you can catch up all the previous episodes as well. Having said that, we will be entertaining all the Q&As towards the end of the session. So while we're presenting, if you have something important you want to ask, feel free to use the question box and we'll be able to take those questions towards the end. And now let me introduce you to our guest, Toni Ramchandani. I'm so sorry about that. A leading expert in the field of AI and ML. Toni Ramchandani is known for his groundbreaking work in the field of AI and ML, particularly in the area of automated testing. He has been at the forefront of developing innovative solutions that not only enhance the reliability of AI models, but also make the testing process more efficient and scalable. Tony, thank you for joining us today. The stage is yours.
hey, thank you Harshit. Thank you for the opportunity and would like to welcome everyone. In the meantime, I'll share my screen, but I just wanted to thank you Harshit for that warm welcome and more than enough uh, introduction, I would say. But yeah, with that, I would share my screen. I'll just briefly talk about myself. Uh, this is my LinkedIn profile. I'm just sharing. I hope you can see this. If you want to connect with me, you can feel free to add over there. Okay, be a guest or be a visitor, and we shall connect on that part. So, I mean, as it speaks, Harshit already introduced me, but I just wanted to touch base upon some of the important aspects that I'm working as vice president in MSCI, wherein I mostly believe in driving solutions at excellence, and I'm working as a tech delivery head. At times, I'm AI research engineer. At times, I'm part of generative AI team. At times, so I've led teams of QA, DevSec, of Databricks, conference speaker, corporate trainer, author. There's a book coming on. It's on almost on the way on journey. It's named as Journey into Generative AI. So that's about me. I like sports. Recently, I'm cycling over there and in the image. But yeah, that's about me. And this is the Medium article I wrote about exactly what I'm going to talk today. So feel free to go there and read more about it. With this, I am going to start with this presentation. Okay, and yeah. So first and foremost thing is it's not only about the automated testing of AIML models. It's also the white box testing, automated white box testing. You can call it. There are a lot of questions which are asked. Um, Many people, whenever I am part of a community or a talk or whenever I meet, so uh, people are first of all disturbed with AI. Basically, everybody knows. People think that there will be job lost and all those stuff. So that is, to be very honest, I feel that is not going to happen, if not to that scale anyway. So don't be worried about it. Just enjoy this time. Basically, we all are in a phase where we are seeing this particular thing. AI is taking us by storm. So enjoy it, and live with it. I mean, find ways to live with it. Okay. So that's about AI, and we know how it has shaped our world. It's everywhere. I mean, you just in the morning when you wake up, you will find AI is impacting your life. When you sleep, go to the sleep, the whole day you will find somewhere or another touch base. AI will definitely touch base you over there. And there are a lot of questions, like people at times ask, testing in AI or testing of AI, right? And AI based testing. So there are a lot many jargons which people throw. At a broader sense, I see it basically in two ways. People are eager to know about AI. One, at least in the testing community, that how we can test using AI, okay, and how we can test AI itself. Test using AI is most often question asked, rather than how we can test AI. And over here, about talking about uh, testing the AI models. I'm not talking about testing with AI model. I'm talking about testing the AI models. AI ML model, you can classify that, right? However you want to, because there are a lot of ways to call it, like AI, ML, deep learning. All of them are like subsets of AI. So you can put in whatever and however you want, but there is obviously a logical description of every field. But in this particular scenario, let's we limit to AI, ML, or DL, however. Okay. So this is my thought, that Swiss Army knife myth. So when we talk about Selenium, when we talk about any automation tool, data testing tool, right? We think that, okay, there is a. I think before this, before I'm conducting this session, there was a joint discussion where going on. They were discussing about AI. What problems AI can create for us, what and how problems are there at every length, and why testing is important to that. I think they made some bold statements over there which are going to help you understand more if you have attended that roundtable discussion. Um, so this is what I feel is basically people often think automated testing is a Swiss Army knife for AI. Okay, which is not the case, to be very honest. Handling everything with ease, it is not possible in AI, at least not in this particular timeline or time frame where we are living in future. I don't know, but at this point of time there is no silver bullet kind of solution which will solve your problem. And it is a good news and a bad news as well. I'll tell you how and why. But in reality it is more like bringing a butter knife to a sword fight. Just imagine like that, right? There is no one tool that can cut through every challenge. This is very important. Why I'm saying this? Because AI is, there are a lot many factors in AI. Forget about AI, but there are balancing, or maybe the supporting topics which you can learn about AI are also very big. I mean, let's say, for example, if you want to learn AI, you must understand what are word embeddings, what are vector databases, what is the mathematical formulation, what are the probability distributions. And there's one feature of AI which is generative AI. One is predictive AI. One is computer vision based. Okay, more of the eyes to AI kind of, and there are a lot many. Okay, but there is no right solution at this point of time. But there are certain solutions which we can implement. So I just now like talked about what is it basically. So what is AI? We all know, right? And how it is impacting us. We all know about it. So what is it? Why it is required? What is the automated testing landscape in this? And what I'm going to touch base today is, maybe you can say, the tip of the iceberg. And there's a lot to achieve and or see or maybe evaluate or create, however you put it. But there is a lot which needs to be done in this space. Which are the key tools at this point of time? I mean, I'm going to introduce a few. There will be more you will find on internet, or while you research, you will say these tools are not helping in LLM testing. So as I said, I mean, there is no right silver bullet solution for this. So for every particular context of AI model or a definition of AI model, there will can be a different or tailored solution for it. So I am going to touch base mostly upon the white box testing of it over here. Understanding and mitigating AI hallucinations. We all know hallucination is a very big problem in AI. I mean, you cannot simply rely on this 100%. Security, ethical implications, future of AI testing, and we can take the questions within the time space. Right. Overview of AI ML impact. We all know how it has changed our world. Tomorrow somebody will come and say that there is a robot which is going to test, right? So you will say what? Okay, so there's the impact everywhere on be it not only a person who is a technical with a technical background, but anybody who is working in any field, right? There are a lot of things, research is going on, so there's an impact everywhere. And the importance of testing, I'm going to touch base. We all know how important is testing in the first place, and automated testing is obviously a wings to it. Ensuring model reliability and security and performance, I'm going to talk about it. um, Now we all know traditionally in traditional testing that there are certain aspects which we can call it as testing or automated testing landscape. So when you compare it with web-based, mostly which we do, or mobile-based devices, so over there we talk about sanity testing, smoke testing, regression, and then there are a lot many aspects. Integration comes into picture, right? Apart from all these, if I closely look at the AI ML models, um, so basically you may have a front end to use it, so you may automate with Selenium. So that's another part, but which is, to be very honest, not so important in the context of these model testings. Um, Now there are tradition. I mean, these are the mod testing types. Basically, are data validation testing, model performance testing, bias and fairness testing, robustness testing, adversarial training testing, model explainability and scalability, performance, etc. You can put more over there, like somebody can shout out there or three, four things, but that's okay. But these are the high level points where we can inject every other new type of testing in the AI space. Ensuring model consistency, efficiency, and early detection of issues. We need to do this for that. Now, um, let me uh, let me first tell you that why data validation testing is very important over here. So we are living in a world where we say data is a new fuel over, okay? And just imagine if we have some data which is very biased in nature, or maybe it is not so complete. You, let's say there is a data for patient and age as value as null, or maybe a minus. So just imagine a patient with -2 age, right? So that is not a model is not going to give you a right set of answers. Or just imagine basically a data file which has, let's say, a data of 1 to 100, okay, a number, that's it, an integer, positive integer for 1 to 100. But just imagine somebody just put 2300, or maybe 230, or maybe 136 in that particular test data. But we are focusing on 1 to 100 only. Our model should focus on 1 to 100 over there. If there is a number which is 230 in my data set, so if model tries to cover that, then that's the overfitting problem, right? And if we want to train our model in such a way that it has 1 to 100, but we have data of only 50 records, 1 to 50, right? So that's underfit. So in both the cases, model is not going to give us the right solutions over there. So data validation testing is very much important over there. Over there you can learn about data analytics and how data is important to us. You can learn libraries like pandas, numpy, to understand it more, how to do it, right? And model performance testing, obviously, I mean, how it is performing with different inputs over there, and whether it's giving me the right accuracy, with the right accuracy, so answers are not right. So in the same case, let's assume that my model, I input as in digit 3, right? So it must give me 3 output because that's where it is trained on. It should not give me 2.95 or that is, although in some cases it's accurate, but I'm trying to convey with this message that with this small data set it must be accurate enough, right? And accuracy is debatable. I mean, everybody can say it's very much contextual based. One can say that this is very important in um, understanding the model type. So if something is related to your health, then it is very important. Finances, it's very important. You will not take 2.9 instead of 3, right? You won't take it. So especially if you multiply it by thousands or maybe in dollars or beyond that, right? You won't take it. So that's very subjective in nature. Model performance testing, it's kind of the accuracy and accuracy, F1 score, all those things. Bias and fairness, basically we must be in a position where our model should not be biased, right? And data can be biased as well. So while training our model, if we are providing the biased data, then the bias and fairness testing will go for a toss, right? Just imagine that to some locality, to some some minority, or maybe some gender specific bias is occurred in your model, and now let's say you are hiring some people and your model is just suggesting one gender or one specific community over there. That's at times illegal as well, right? In some cases, um, we must understand robustness. Like, we must do adversarial testing. Now, what is that basically? So you throw tricky inputs to the model, and it should not give you the incorrect answer. Okay, so that is adversarial training testing basically. Over there, you like in the same case of 1 to 100, where we have trained the model. Over there you will say 2 plus 3, right? Which is kind of an adversarial attack on the model. It should give you 5 because we all know that's 5, but whether your model is understandable enough to do that, or maybe you can take any other example, 2 multiplied by 3 or something like that, right? Model explainability testing, this is one of the very complex part. Even the people who create model will most of the times can never tell you. It should, like, it is like, if your model is giving you some answer, then why it is giving that answer? Do you know? I mean, model knows? No, we don't know, right? Most of the time it's black box. Okay, so that's where the problem occurs. Can we rely on it? I don't think so. I mean, although it's giving us outputs which we need, but you never know how, when it is going to slip from your from the hands or from the situation, right? Scalability and performance testing, like we all talk about, like how scalable it is. Tomorrow it's 1 to 100, but just imagine up to infinity, numbers up to infinity, whether it's going to help us or not. So all these kind of testing are required for our AIML models. Now you need to suit up AIML testing armor, all the prerequisite you need. Many people say that, okay, I don't know how to deal with it. I don't know what to do because I don't understand a bit of AI, and forget about the intrinsic working of it, right? So there are not many questions, and those are fair questions. And not everybody is, a genius over there to understand it. But how we can proceed from here? Okay, you assume you are at 0th step, right? So you must, first of all, you should have a reading habit. That's that's the foremost thing. Problem solving skills. If you go and if you can, analyze the problems and then solve it, you are better than that. You will become better every day. So that is one skill you must have. Okay, problem solving skill. Forget about if you want to come in AI space or not. You want to keep away from yourself. And then there's a reading skill. I think these two are, must have for everybody. We are living in the world where everything is changing, so we need this strong understanding of AI ML concepts. We must read about what is supervised learning, unsupervised learning, semi supervised learning, and reinforcement learning. Those are the machine learning understandings. And then how AI, what is deep learning over there, what is a neural network, how they work basically. We must understand these at length. To, in fact, even if we are not testing it, while you are using it, okay, you must know about it. Knowledge of testing methodologies, which we talked about. You're good in, must be good in programming. I think Python is a way to go in AI these days. So That is a primary skill which everybody should have. Ethical and legal considerations. We all know that, like, how ethical AI, and everybody is creating frameworks around how to use AI, use of AI, and etc. So computational resources, obviously, way back the why AI was not so much happening, because there were computation and data resources were not available there. Now the presence of cloud and computation powers, GPU, like NPU, TPU, everything is there. So um, it's way beyond CPU now, right? So communication and documentation collaboration with goes with every kind of work. Um, what are the basic tools? I would say, like DeepXplore uh, is a differential testing for neural networks. Now, new I want to cover in implementation as well, so I'll just very go fast on this. DeepXplore is basically, it's check the neuron coverage. Now, what is neuron coverage? Basically, it's very simple, that in a deep learning model or in an AI model, it's a neuron based model. Now it is derived from human brain, right? For example, if I ask you to what is this, you may say mouse, because you have seen this, right? Less neuron fired in your brain. But just imagine I give you a complex picture and just ask you to understand what is it. There will be more neurons fire in your brain. You will try to apply some logics to understand it, what exactly it is. um, and one neuron may pass information to another, and you get an output. So input is image, and then you get the output. So that's how the neuron works, just to in a very short space over there. DeepXplore is kind of how much neuron coverage happened during a testing of a model, right? Maybe let's say there were 5,000 neurons which were used over here, but even it should be using 7,000 instead, or 4,000, or however you can put it. But that's how DeepXplore. But it's very complicated task uh, to put DeepXplore into picture. Now, SHAP is something shapely additive explanations. So this is kind of the white box model, which gives you why the output given by the model, what is the output and why that is coming out of it. So which thing got more weightage. So just imagine I give you example of an image. You may say, okay, that's looking like a cup in the image. Why you are saying that, right? From where these thoughts are coming? Because your mind is trained in such a way that if something is cylindrical in shape, open, with open, there's no lid on it, and there's a handle, you call it as a cup, right? And that's where you are coming from. But there's, you have given weightage to it. A cylindrical shape, it's like complete, it says like 60% of weightage I'm giving to this shape, because this is more of a cup. Handle, I'll add 20% more to it. And then open lid, or maybe some design which you know on the cup. So that's where you giving some weightage to it. And that's what, which weightage. So SHAP is something that clever hands basically is something, adversarial testing framework. It gives tricky inputs to the model, and then expects model to give output, exact outputs. You can read more about it, or maybe in your future, if whenever I get chance, I'll take about it. Full box is similar to clever hands. Basically is customizable adversarial testing. And over there it covers most of the tricky inputs. Now, what we need to do, why do we need, how we can mitigate this AI hallucination, which is main problem in AI. So basically, I talked about overfitting. I talked about bias training in data. I talked about model architecture. So we must be in a position to understand which model we need, right? For text generation, you use ChatGPT, but it is a transformer model. Okay, generative pre-trained transformer. You cannot use diffusion model over there for, I mean, you can in many ways, but not, it won't give you right solutions. Or maybe for image generation, you simply don't use ChatGPT, right? You use something else. Why we are doing that? Because that model is responsible in such a way that it generates the images. And we talked about this testing, so I will skip this part. Fairness, transparency, accountability, these are very important aspects. And now what we need to do, before I jump to the demo. Emerging trends, continuous testing, it must evolve. AI driven testing, we must use AI to test AI, because all the permutation combinations cannot be done with automated or either human as well. but these are code-based testing which needs to be done. A lot of challenges. Okay, I can fill this particular entire Excel sheet with this. Testing for adaptive models, scalability, collaborative testing, open source contributions. So this is a lot of challenges which um, we don't know what is happening under the hood at times. Why person is selecting that, developer select that model, so on and so forth. We must understand all those aspects, right? All those are challenges for us. Before I go to Q&A, I just wanted to showcase you the demo of it. Um, this slide I think will be shared with you. This is Google Colab, by the way. If you don't know, this is a cloud-based solution for running the Python over there. There are a lot of it has GPU and TPU. Go and just search Google Colab, log in with your Google account, and bingo, you can use it. It provides you the RAM and hard disk and all those things. Good thing is it is preloaded with a lot of machine learning and AI based libraries like TensorFlow, maybe PyTorch or not, I don't know, but TensorFlow is there, Keras is there, which is a deep learning library. Okay, so what we are going to do over here is we are going to first of all install Torch and Torch Vision and NumPy. Okay, so we are first going to create a basic CNN model and we are going to test it. Uh, Basically, the white box testing of it in an automated fashion. Okay, so first of all, I must tell you that what is a CNN. So basically, CNN is a kind of deep neural network which is well suited for image recognition processing task, made of multiple layers, convolutional layers, pooling layers, fully connected layers. The architecture of CNN is inspired from visual processing in the human brain, just like we visually process things. Well suited for capturing hierarchical patterns and dependencies within the images. So it is good for the grid data. Images are grid data. You can just imagine pixels is one grid or maybe one data in the grid. That's where you it fits the best. Um, Convolution layers basically apply to the input images and just to detect the ages, texture of the image, complex pattern within the pixel, so on and so forth, and their activation functions to find uh, learn complex relationship between the data, which is like maybe pixel color is let's say green, and then the next pixel is red, so probably you will understand this is there is some relation the way pattern it is changing its color, and hence it's creating that image which we can see. Fully connected layers, I mean these layers are talking to each other. Every neuron is talking to at one layer to next layer, and hence it is giving us the solution over there. um, so you can see I'm just now I'll just go and install these libraries. Torch library, it's basically the machine learning or deep learning library, you can say. Most of the time, as I said, I mean these libraries are already installed um, on Google Colab, so that's a good sign. But even if it is not, then you can simply go and you can do it. Many of them would be like NumPy, Pandas are there, which would have been already available. I would urge you to learn about these Pandas and NumPy, whether you are testing AI or testing with AI. I mean, doesn't matter. Okay, you need to do that. This is may take time. So in the interest of time, I would quickly go and explain you the next portion of it. Now we are going to import the important libraries over there. Torch, a core PyTorch library for tensor operation. Now, what is tensor? Basically, everything in machine can be seen as a vector, okay, and combination of vectors, which is a matrix basically, which you might have learned in your academics or in schools. The matrix operations, which are on slower side, but these tensors make it very faster. Hence, I mean, by the way, TPU is derived from tensors only, right? Tensor processing unit. So why are those? Because the complex, what you can say, complex multiplication and complex numbers utilization. So they do it fast in vector form. Torch.nn, we are defining a neural network, right? So we are going to create a CNN, and that's what we are going to test. Optimizer, so we are using Adam as the optimizer. Okay, I'm not going to explain everything because there's been limited time. torch.nn. Functional includes functional like ReLU, cross entropy loss, etc. Um, so data set over here, we are going to load data set. Torch Vision has some data set predefined or by default over there, which we are going to use. This is going to provide access to MNIST data set. Now MNIST data set is, you can just imagine numbers, zeros and one, handwritten digits, images. So that is the MNIST data set. And so that's on those are the images of handwritten digits. Transforms allow to pre-process and transforming the data set over there. We can work on the data set, and we can pre-process it as with respect to our needs. Data loaders, I mean, as the name suggests, it is going to load and shuffle the data set. NumPy for numerical operations. So that's how we are going to import these libraries, and then we are going to define a simple CNN model. Okay, but you can replace these models with whichever model you are going to test in with this condition, with this case. A simple CNN is defined with two layers, convolutional layers over here, which are going to extract the feature from the input images, and there are two fully connected layers which perform final classification. So with this, it is going to classify the images, MNIST dataset images, and over here, this is the method which is going to create a simple CNN, and over here, which we are providing neural network module as maybe you call a constructor in Java. So we are providing that particular. We are creating a constructor over here. Now, what we are creating basically, we are creating two layers, right? We said two convolution layers, which has these, you can say, how can I put it, um, nth level, okay, like 132 3 and 1 basically, and then 32 64 3 1. So all these are the um, I don't know how I can simply say it off, but just understand the size of image, maybe matrix wherein we are providing the layers basically. Okay, and we are creating a linear function with some mathematical computation which we are using over here, which is going to create or transform our pixels into this particular fully connected layers. And we have another fully connected layer which is 128 by 10, which is going to create some, you can say, the classification images over there. And we are creating a method which is a forward method over here, wherein we have a variable which is called as x, a parameter, and we are passing all these created convolution networks and uh, uh, linear rectification methods to this particular variable, and we are just assigning some values which are passed as this particular value into x, and then this is going to create um, a feed forward network with these particular things. Okay, I'm just simplifying it so that people who don't know about anything about it can understand, uh, and people who know may guess about it. So yeah, I mean, when I say guess, I mean you can understand more about it. So we are creating a feed forward network from this, and this is going to return this particular variable to us. And now we are going to load and normalize the MNIST data set. Images are converted into tensors and normalized with a mean standard deviation suited for MNIST. Now, what does mean by this? Um, a image is basically an array of numbers which are pixels. Okay, you can give any value to them, and just imagine it is a matrix over there. It, from the left to right, right? We see an image. It has x and y coordinates. So those are the and there are 3D images as well. So these are converted into matrix. Okay, and then normalize with a mean and standard deviation suited for MNIST. Now you will find that in MNIST data set, one picture is picture perfect, but the another picture is um, have some blur thing, or maybe it is not well. So that means there is some standard deviation and mean associated to it. These things which we might have learned in our schooling or academics in college, what is standard deviation? So it is just a deviation from the normalized one, or maybe But in the first, okay, let me show you what how MNIST dataset looks like, so that you can get a picture in your brain and you understand more about it. Let me open a couple of uh, images over there if it has images. Uh, I don't see. Yeah, see, this is the images of numbers, and it has label as 7, 8 for 8, 1 for 1, and these are the images which our module is going to classify with respect to this provided label. Now you can see this label is little bit blurred over there, and this is better than this one, but not exactly 100% better. Um, so that's how there is some standard deviation than the actual image over there, right? So this is going to do that. Train loader and test loader, basically, so we are going to create a training data set and test data set from this particular database data set. So I think there are around 380 or I don't know, maybe more, 1000 something like that images of these numbers. And just imagine we are going to take 80% or 70% of data as test data and train data, basically, and then remaining 30% is for testing the same model which we are going to create. Now we are going to load this data set, and we are going to transform this in a tensor so that a machine can learn about it, right? So we are going to convert into two tensors, and then we are going to normalize, and we are providing certain mean and standard deviation values over there, so that it transforms in a way that we must need or maybe required. Okay, and then we have created one variable called train data set, and we are loading this particular data. We have kept these options: download, to transform. So while transforming, it's going to call this, and this is going to convert into these vectors or the matrices, you can say, tensors, however you want to call it. Test data, on the similar lines, we are going to call it, and we are going to load these variables. Train the loader, so basically we have created data loader method, wherein which we are giving batch size of 64 and shuffle equal to true, just shuffle the images. And in the test loader, we are going to give the batch size of 100, and we are going to shuffle as false. Okay, now these are variables which you can change and see the output, whether how the frequency or sorry, the accuracy is coming. Now, in the interest of time, I'll just cover real fast over here. Initializing the model, loss function, and optimizer. We are creating a simple CNN. We are calling this from the PyTorch library. We are providing the optimizer to it, and then we are going to create a method to train this model. Now, till the time we are not testing it yet, we are just creating a model and training it. So we have created a model. Now we are going to train it. We are going to provide all the necessary inputs over there, and we are going to train it, and then we are going to create a batch size for training purposes, and then we are going to data and target. We are going to load all these. We are going to apply the optimizer, and then uh, we are creating the output, which is model is giving us the output which we created CNN, and over here we are passing the data for which we have used for train. Okay, and there is a loss. Now loss function. Now what is loss function? Just to say in a very quick succession, uh, going back to the example where I asked you to understand a picture of a glass, or maybe a cup, right? So over there, let's assume that was not a cup, that was a jug, or that was a bigger glass, right? So you were near, but you were wrong, right? So there's a loss information, or so maybe you were saying that, okay, my assumption was 80% correct, but not 100%. So those are the 20% is your loss. You can say point 0.2 over there. So that is the loss in nutshell, just to help you understand in a very simpler fashion. And over there, we are going to train this model on CUDA, which is NVIDIA based device for faster computation over there. If it is not, then else CPU. So we are just passing this command so that if it is CUDA is not available, then run on CPU. Over there, we might have this with GPU available. So, but we are connected with one CPU, I think, and you can change by going to change runtime type over here. You can explore Google Colab, and you will understand about it. Now we are going to call this train method. We are passing the model, device, and device which we created like GPU, CPU, whatever over here. Train the loader optimizer, and one being which was the function which was epoch. Okay, epoch was one. Now epoch is number of times it is going to train. I have deliberately kept one because I just want, in the interest of time, I don't want to waste a lot of time. Um, now this is our model is trained so far. We have created a model which is trained. Now it's time to apply some testing over there. So we are going to create a function which is going to provide adversarial input functions. Now I told you what is adversarial testing over there. Provide incorrect input to your model, and or maybe complicated tricky inputs, it must give you the right answers over there. So with this method which we have created, we are parsing the input image, target label. I showed you label, right? For image 1 there is 1, for image 4 there was 4. Epsilon, which is point 1, which is kind of we are changing the behavior of this particular maybe you can say input image, but more to this, I mean, we need a detailed session over there. uh, we are going to input this image, and then we are creating the output by calling this model and passing the input image over there. And now cross input entropic loss, I told you about what loss is, so it is going to calculate. There are many types of loss. And then we are going to run these two methods, which is a zero grad and backward. Now with this, basically it is going to see where it has impacted. Okay, and perturbed images. Now for example, which image it was not corrected successful or not, you can say validated or classified correctly, it's perturbed image for us. And over here, which we are going to give a basically a percentage number to it, that this image is not predicted, and what is the percentage of it, I mean, in terms of probability over there. And then we are going to call torch clamp, ensure image remains valid in range. So we are not giving anything which is way beyond, like, and you can say, okay, this is not going to beyond the trained data set, or sorry, test data set which we have provided. Now we are going to create a function for maximizing neuron coverage over here. And over here, I'll just very quickly go that we will calculate the this particular permitted images, and we are going to detach the image, and this model is this calculation is going to give us um, the neuron coverage which it covered basically. And then we are going to test the model. This is our test method, which is going to call obviously the previous methods. And over there, which we are going to over there we're going to provide the actual, um, we are going to count the discrepancies, total samples which we provided, and we are going to call this methods. And we are going to calculate the accuracy. You can simply call this test model method, and this is the final output you will get. Total sample tested were 10,000. um, 9,865 were rightly tested with uh, accuracy of 90.65, which is we calculated with neuron coverage. And then corrected predictions with perturbed images were 1436. So there were these many discrepancies found over there, which is 85.58, right? And that's exactly where I have trained this model and executed. See, this model trained on like for 10 iterations for one epoch. For every iteration, it was, you can see, it was correcting itself, and we were getting different results. More it is trained, more chances that it is going to produce the right output. I mean, this is 10 iterations are very small in nature, to be very honest, in real time world, but that's how it is for a demo purpose. And then in this particular thing, we basically I was going to implement SHAP and full box as well, but in the interest of time, that would have definitely gone out of the wire. So I'll just quickly come back to this slide. This is where you can connect me, and I'm open for Q&A. Harshit, shall I stop sharing now?
Yes, yes, let's do that. We are short on time already, but I'll quickly
Yeah.
present some questions from the stage. Thank you so much, Tony, for that detailed demo, by the way, step-by-step guide to the entire model. So we have, okay, so a lot of these questions are rather vague when we have already answered them during the conversation. But yeah, there are some quick questions that I want to present here. If you have something to shed light upon these, how can SHAP be effectively utilized to interpret model predictions and enhance transparency in AI/ML model?
See, basically, first and foremost thing, SHAP is used to, I mean, understand the feature and the weightage on the feature by from where it is coming. Okay, um, by, I mean, at this point of time, this is the best library I would say we have, or people have, you know, produced so far. I mean, it's not 100% sure. It's not 100%. That's the pain problem. But I think this is the best we have. So if you want to read more about it, you will get better understanding. If you want, I don't know how, but where I can conduct this session about it, but I'll definitely try to find out where I can conduct and reach to you guys with a demo. But by far, this is the best library to understand the internal features of weightage. I've given you an example wherein at times you say this is a cup, right? And by the base, looking at the base and shape and size of it, it's almost certain that it's a cup. And 60% of weightage I'm giving to the size of it, and the handle which I see on the right hand side or on the left hand side, I give 20% weightage to add more that there's a cup, right? And there may be certain designs, or maybe it's written it's my cup, right, on that. So I'm giving just 10% or 5% to the aesthetics of it. So what I'm doing actually, I'm just providing or trying to understand which feature will give me what weightage to understand that I'm predicting right? So if my understanding is completely wrong, that a cylindrical shape just like this is not a cup, right? It's a glass. So my understanding is gone wrong, but over there I provided some weightage just because of that shape, right? Now SHAP is doing exactly on the similar lines, may not be the same but on the similar lines. Mathematically it is trying to calculate which features were selected for classification or understanding of the model, and then it is going you according to that it is going to go to output. Now it is self designed on top of the neural network. So basically that's where it goes and checks those parts. More to this maybe I can cover at length, I don't know when, but yeah.
Yeah, that I hope that answers. We've already extended the time limit, but we'll just take this one last question. How can QA teams effectively validate the performance of these and reliability of these models, especially when dealing with complex data and evolving algorithms?
See, I there are not the single answer to this, Harshit and like Himanshu. There's no direct answer to this, to be very honest. And I will say it is bad answer, but it is there. Okay, that's what it is.
No,
At
I
least
believe
for now.
Himanshu should be able to sync and share more details
Yeah,
with you over the LinkedIn
yeah,
channel for
but
that.
but I'll try to answer my what I was just answering it, that there is no um, right answer to it. That's what I'm saying. But I'm trying to answer it basically. See, how a QA team, right, effectively tests. So as I told you, like 3 to 4 things which you have to incorporate in your life, okay, in your day-to-day job, in your QA team's job. One being they must understand Python, to be very honest, because every model is trained on that most of the times, using that language created on that. So you read about Python, make a mandatory thing that Python should be primary choice for them, and read about pandas and numpy. Create a reading habit and understanding habit, implementing habit. If you do this, you will understand data more, right? Once you understand data, then probably you will be in a position to go a next step, which is understanding the complex algorithms. You need to create a reading habit, try to be a problem solver, okay, and try to be in a position that see, at times what happen, QA teams just have a poker face when developers are discussing about certain things. Why that is so? That is a big problem, right? We need to somehow go out of it. And how we can come out of it? If we understand, we read more about things, we enhance our knowledge. That's where you come into picture. If you understand machine learning models, okay, everything. Okay, one friend told me that, okay, Tony, yesterday I read about Microsoft launch Phi model, Phi 3 or Phi 5, and then Llama came, they launched this, GPT launched this. How I'm going to understand this? I don't know. So I said to him that, you understand Selenium, right? He said yes. So in Selenium, if something is changed, let's say 3.4 or 4.2 version came into picture, do you worry like this? So he said, no, I don't worry like this. That's why, because you have strong foundation, right, on that part. So if you understand machine learning models, what is supervised learning, what is non-supervised, reinforcement learning, read about it, try to implement at least one algorithm of it. You understand the deep learning transform model, and uh, and pick a line over there. OpenCV is more of a visual AI models, and textual or NLP is most of the transformer model, right? So if you pick one area and be good at it, and maybe just understand transformer model at very length, okay, go read paper and just watch a few videos, you will get a better understanding of it. Hence, you will never be worried about whether ChatGPT 4 come, 5 came, at least in this context. Now tomorrow AGI will come, which is artificial general intelligence. This whole things will change soon. So, so the answer is, I mean, there is no direct answer, but all these things you need to be culturally start adopting, right? That's the answer. And then only maybe down the line, 6 months down the line, you will see something out of nothing, right? So that's the answer. At this point of time, you can reach out to me on LinkedIn, and probably I can guide you that how and what can be done over there. But you have to be efficient in programming, for sure.
Yes, so change is the only constant, and you have to get your hands dirty. And we have the expert Tony, and he shared his LinkedIn over here. I have also pinned his, LinkedIn profile link in the chat box. Having said that, we would be wrapping up the session over here now. We have other sessions lining up, already running. And thank you so much for everyone who has joined us for this session. Tony, thank you so much for that detailed demonstration and taking us deep into the knowledge of AIML models, and for taking the time out of your busy schedule. Thank you so much, everyone. Take care. Happy testing.
Thank you, Arshit, and thank you so much for everybody. I could see some emojis floating around, but thank you for them.
They were floating around all the time, trust me. Even when you were presenting. So
Oh,
yeah,
thank you.
thanks everyone,
Yeah.
thanks for being the
Give a
energy
love,
app.
guys.
Thank you.
Yeah.
Yeah.
Bye.